Hello, and thank you for joining today's webinar. We'll learn how to develop a custom VUI for children's speech with our partner, Generalplus. My name is Anu, and I'm with the marketing team at Sensory, and I'll be moderating and speaking during today's webinar. I'll start with a brief introduction of my fellow panelists, and then we'll continue on with today's agenda. Again, my name is Anu, and I'm on the marketing team at Sensory. Jackie is a marketing manager at Generalplus. Jeff Rogers is with Sensory, and he is the VP of Sales. George is a project manager at Generalplus. Today's agenda is as follows. We'll begin with company overviews, starting with Jackie with the Generalplus company overview, followed by myself, where I'll provide Sensory's product and company overview. Then Jeff will share a demo where he'll create the VUI for children's speech using VoiceHub. And that'll be followed by another demo from George with Generalplus, who will deploy the VUI into the Generalplus integrated circuit. We'll close with a brief Q&A, and those questions can be submitted throughout the webinar. And that'll wrap things up. With no further delay, I will hand over to Jackie.
Yeah, thank you, everyone. I think that's very exciting to work with the Sensory, as we know the Sensory was the best voice recognition offline vendor in our industrial. I am very sure to say that way. For some people who will know the toy business, know what is the reason. So after a while, we're working for almost like 2 years, actually 2 years before, just right after the COVID-19 was just a little before the 19, we started to work together. And we actually work with the Sensory to put the Sensory technology start to put on the Generalplus hardware. So actually, I think that's the very, very good of the combination. So Sensory can provide a lot of the IP in the software, and the Generalplus provide hardware to put into the consumer product line. So basically, that's what I try to explain. Where is the Generalplus come from? So basically, we are a Taiwan-based of a fabless IC design house, aka like an IC design house, and we actually take a lot of the IC design for the consumer electronic, which is aka toy and also like home appliance, those kind of electronic stuff. And mainly, we basically, like I say, we do the interactive toy, we do the electronic education system, we also do the multimedia like AI camera. Also, we do a thing like a dash camera for the car recording. And also we do the home appliance and also cell phone accessory like a charger, those kind of system. And you can probably find out a lot of information from our website. So let me just dive into what the Generalplus actually have. So we actually cut our company into 3 major of the product line. So basically around like 17 years before, we actually spin off from one of the big design house in Taiwan called Sunplus. So we are the toy department that time. So basically that's the first one in the left corner here. So we are the consumer electronic, and we have an 8-bit microcontroller, 16-bit microcontroller. We do like a speech, flash and light, sound, and also we do the black and white LCD control. So that portion as today is still a very, very big portion of the toy business in the worldwide. And after that, around like 10 years, our company started to grow up, and we become a published company in the Taiwan. And we start to create a second product line under the hood. It's the multimedia. So that's because people start to using more and more the color display kind of stuff. And also later, the camera, CMOS camera started coming in. So we actually built our 16-bit the video SoC to do a lot of the TV game, LCD handheld game. And then later, as today, we start to do the 32-bit the AI chip. So it's the multimedia chip with the AI capability inside. And on the side, we actually have a last third department called MCU. Basically, it's more like home appliance. That's because in the South China, there were so many factories. They have a good assembly capability, but they don't have any R&D. So compare with the consumer and the multimedia, will provide a chip and SDK. So our customer or customers engineer, or they hire someone outside can do a design. In the MCU line, basically we more do like turnkey service. So they do like a e-bike. So we are the motor control basically is e-bike. We all have had like 60% more of the market share in China right now for the e-bike controller. And also we do the touch controller for the home appliance, like a LED table light, like a fan, like a air fryer, those kind of things. And also we have a department doing the wireless charger, which is like a cell phone wireless charger from retail, and away go to, right now we actually deliver into like a beauty market for the Ford and the Toyota. And also we have a very big portion to doing the remote control. So this is like a 3 different section of product Generalplus maintain. We have around like 300 to 400 different products under this 3 section. So let me give you a little bit easy way to understanding what the end product look like. So in the first section, I talking about the consumer. So the LCD can be like a watch, timepiece, can be like a sport meter or calculator. And in the speech and melody product, we actually did a lot of the toy, almost like most of the like people know, well-known best-sell toy. And also in the low-bar side, we also do a lot of the high-end stuff. And for example, we do like a BBA, R2D2, this kind of stuff. And we do the mechanical low bar. So those kind of things actually is one of the reasons we actually dive into the voice recognition, because all those kind of interactive product will require very, very good voice interface. And the second of the product we call the multimedia. So this one from the start on the right-hand side. So basically, because we start from like education toy, so we have a lot of the graphic card, color display output, and we have a gaming system. Basically, it's we call PPU. It's like a graphic card inside the chip. And also you can see this is like a Tamagotchi, like VTech watch, and also do the camera with the green screen. And also we do the HDMI output of the dance mat. So this is where our multimedia line start with. And once this thing start, then it start become into the even high-end low bar compared with the first slide. So we do so many interactive low bar, which is including the local voice recognition and the crowd version by the Wi-Fi. So actually they do the mix mode. When Jeff comes in, Jeff will be explain what is the local THF plus the sensory AI crowd. And also in this portion, we start to go into the high end of the home appliance, like a floor cleaner, low bar, those kind of things. So the reason we do that is because right now the free floor cleaner low bar already have some machine vision inside the chip. And in the turnkey portion, actually, because it's camera chip, you can use it for the graphic engine and also the camera input. It also can be using as the standard solution, like a dash cam, like a video conferencing, webcam, doorbell, and like the video drum, this kind of application. So we actually in the China, we have some of like a turnkey service to provide a semi solution for the people in the factory side that can very quick for go to the product. In the third portion of the Generalplus, basically, like I say, it's more like home appliance. So we actually have a wireless charger. So the wireless charger, we're talking about like a standard retail version of wireless charger. It's like the thing if you go to Costco, there was like a lot of the wireless charger. More than half is Generalplus inside. And also other than the standard wireless charger, we're also doing like a built to home appliance, built to like a THS headset, and also we do the auto built market. And the touch sensor, that portion basically is like air fryer, like a thermal cat, this kind of thing, and the remote control and the e-bike. So that's kind of like a 3 major things of the Generalplus doing. So let me go into the chip we will be talking about today. I think today we try to do is to say, we try to demonstration how we can run the sensories, the high-end THF algorithm, and the output the model from the database in the VoiceHub. And so this chip actually is what we select to start with because they need enough of the CPU power and the RAM. So we pick our GPM43 series. This is a Cortex M4 chip inside with building a 128 of the local memory, and the embedded inside the chip actually have embedded a 64 to 256 DDR memory. And also you can support the NAND flash or SD card outside. But one of the major reasons we pick this chip is to say because when the start we're using the DRAM to make it easy for the porting, but in the long-term roadmap, this chip actually can run the program directly from the SPI. So that was the possibility we can use like a GPM41 series, which is a no DRAM version, just a CPU. And we run the code and the model directly from the SPI to make the whole system slow, the cost down, and also make it simple. And this chip also including the sound processing unit up to 16 channel of the SPU, the sound processing unit, just like a sound card. And it also provides like a JPEG holding and a TFT output. And of course, this chip will be supported up to today's the VoiceHub and the THF V6 version. And also I want to mention about like how the whole multimedia product line we are. So you can see this is like a 1, 2, 3, 4, 5 of the major chip series we are selling today for the multimedia. So the GPM4 series is here. So this is like Cortex-M4. And when go up, we have the GPM329, which is ARM9 and around 500 megahertz. And the best thing of this thing, they actually got ISP. So if your application require more than an audio, this chip actually can come direct from the sensor and go up to the 1080p H.264 codec output. And actually this chip is the one beyond, this is under developing. So GP877, this chip basically is our newest chip. The major thing different than this one, so this is just compressed and display. And this one actually can go to AI. So we actually have hardware inside to run the CNN, so support the TensorFlow. And also this one from 2D graphic engine, go to the 3D graphic engine, and the codec capability up to like 2 channel of the 1080p H.264. And the middle, this chip we are under developing because we try to get something in between these two. This is almost like a same spec, but this one will be add the TensorFlow into this chip. And below this one, we actually have a GP328. I think this is one other chip I was working with the Sensory right now. We try to using the SRAM inside of the chip. And this one actually run the tiny machine learning model also. So this is a whole library of what the Generalplus roadmap in the multimedia. And today we work with the Sensory for the GPM4. And later we may be down to the 41 or even jump to 328. Okay, so last I have. Does Jeff come back? No. Okay.
No, Jeff, but I will go ahead and provide the Sensory company overview, and then we will dive into the demo from a brief abbreviation of the VoiceHub demo, and then we'll hand off to George to show how that VUI is implemented.
Okay.
So now go ahead and give me a moment and I'll share my screen and tell everyone a little bit about what we're up to at Sensory. Hello, everyone. So who's Sensory? Sensory's been around for about 25 years. We work with major companies, as you can see from the icons here. We are pioneers in Edge AI, and we develop voice and vision embedded technologies. And also, more recently, we now develop as well the Sensory Cloud. So like I said, we've been around for quite some time, and we have had really lots of products, billions of products shipped with Sensory voice recognition. And today, what's really exciting is now we have a easy to use and easy to implement voice recognition specifically built for children's voice. So what's really, and later on, we'll show you how we've implemented that to create a voice user interface. So a little bit about the technology suite. We have Truly HandsFree, which is our well-renowned wake word and command set technology that has been implemented again and again. And this is for typically small command sets and wake words. We then have Truly Secure, which is our biometric face ID, and Truly Secure Sound ID, which detects home sounds and can be programmed to recognize a variety of sounds. Then we have Truly Secure Speaker Verification, which is again a biometric voice specific biometric application. And Then there's Truly Natural, which is our large vocabulary continuous speech recognizer. And we can work with both Truly Natural and Truly HandsFree in VoiceHub, which we will see a little bit later today. And VoiceHub allows us to create VUIs quickly and easily using an online interface. And we'll see today how that's used to create a VUI for children's speech. As I mentioned, Truly HandsFree has been widely deployed. It's a multi-phrase technology that recognizes and responds to dozens of keywords and phrases, and has been deployed in millions and billions of products. And with the Generalplus chip specifically, we can run Truly HandsFree speaker verification that supports an enrolled fixed wake word and a user-defined fixed wake word with speaker verification. So this allows the wake word to be tailored to the user. So the speaker verification ensures that the wake word or the algorithm recognizes specific users. And we'll see that a little bit later. As I mentioned before, Sensory Cloud is our latest AI, and we have speech to text, face and voice biometrics, and wake word revalidation. You can visit sensorycloud.ai and try some of these demos live. And the kids model that we will be using today is also supported in our speech to text cloud, which is really exciting. And the VoiceHub portal, as I mentioned, is an online VUX developmental portal, which allows developers to quickly create wake word models and custom language models for prototyping and proof of concept purposes.
This is Sensory's VoiceHub tool, and in partnership with Generalplus, I wanted to show you a quick project that we can build here that all runs on Generalplus. So the first thing I need to do is start a new project. So you can see that there's a few different options here. We've got Truly HandsFree wake words. Wake words can be always on, always listening. They can run low power. We can have multiple wake words or a single wake word. We also have Truly free hands-free simple commands. These are commands that are like a series of wake words, so that after the wake word is said, you can say one of these commands, and even if you say other things in and around the commands, they are still spotted. So it feels like a natural language experience. And then we also have our Truly Natural, which runs on a more powerful Generalplus platform. Today, I'm going to focus on Truly HandsFree, these two. So the first thing I need to do is create a new project, a new custom wake word. So for the demo, we're going to use Pikachu as an example. So I'll just call this Pikachu for my project name. Then I select the language that I want. You can see that there's a lot of different languages that are included in VoiceHub. And in fact, we've also added US English Kids. So for a toy product like Pikachu, I'd want to use US English Kids for my language. So I select that. The next thing I do is I select the size that I want. This is the acoustic model size for the technology. The larger the size, the more accurate, but it also means that it requires more MIPS in memory, obviously. So it depends on the platform that I'm running on. In this case, for a low-cost toy, I want to use a very small size, like the 80 KB model here. And then the other thing I do is I choose the output format. And so here I just choose our partner Generalplus. And now whatever I create here is going to be automatically formatted for Generalplus. You can also see that I've got operating points here. So operating points, a single point or all of the points. A single point is going to be faster as far as the build time. All the points is going to take a little more time, but it basically builds a frontier graph with false rejects on the left side and false accepts running across the bottom. And what the tool does is it auto generates all of this and creates a model that's pretty well balanced between false accept and false reject. So VoiceHub is a tool, again, that we can use to create these custom wake words There's no data, there's no recordings, there's no linguist touch, there's no hand tuning, there's no speech technologist. I literally type it in, hit build, and I have a custom wake word. So here, I'll type in the wake word. Now, if I type in Pikachu like this, I'll type it in like this, Pikachu, which is how it's spelled, and hit enter here. And then you'll see over here this little speaker icon. This is going to play back TTS basically of what the recognizer is expecting to hear. So let's listen to this.
Pikachu.
So the recognizer based on these letters here, it doesn't sound what I'm expecting it to be. So instead of that, what I'm going to do is I'm going to phonetically spell this a little bit differently, like that, Pikachu, and then I'll hit enter.
Pikachu.
Okay, so that sounds like what I would expect. So here you can see that I'm phonetically spelling it because it's obviously a made up word or a proper noun, I guess, in this case. So once I'm done with that, I've got everything I want. And you can see here that I can enter more wake words. So I can have up to 10 different wake words, always on, always listening if I wanted to. For this project, I'm just going to do the one. So here, I'm all done. I hit build down here. Once I hit build, well, let me show you the process here. It's going to come up and it's going to say, here's the SDK I'm using. Here's the name of the project. I'm doing it for US kids. The size is 80 KB, and the format is for the Generalplus M4 base chip from Generalplus. Once I hit continue, it'll take 40 to 60 minutes to build that custom wake word. So rather than do that, let me just jump ahead. It's already built, and I've already got it included here. So the next step is to create my command set. What do I want this product to recognize? So here I can again, I'll call this Pikachu commands. I can select the language that I want. So in this case, I'll do US kids. I've already selected the wake word because I already created that in the last project. And then I can create the size I'll select the size that I want here again. So, I can go really small, I can go bigger. I'll do 128 for this one here, 128 KB. And then again, I've already selected the Generalplus chip. So now I come down to commands, and I just type in the commands that I want, like thunder shock. And then I just hit enter to go to the next one, quick attack, discharge, thunderbolt, wild charge, and how about thunder storm? Type in those commands. Those are the ones that I want. So same process, go down, hit build. In this case, for a command set like this, it'll take probably a couple hours in VoiceHub server to create that command set. And so, this is all part of truly hands-free. So so I hit build, and you can see again all the details. It's these are my Pikachu commands, US English kids. The size is 128 KB again for Generalplus. So rather than do that, I've already got it built here, and so here we have it. Here's my Pikachu commands, and the wake word's already selected. The commands are already in here, and so here I can download the model. And there's two ways to test this. One is I can test right here on my PC or Mac, and so I just hit connect to media device and I can test there. Or I can download the model, and if I download the model, there's two options here. First off, you can see the total size of my project is 251 KB. So that's got the 80 KB wake word and the 128 KB command set, I believe. So two options here. One is using my mobile device, Android or iPhone. I can just scan this QR code, and over here you see my mobile device, and you can see that it's on and listening right here. So this is our VoiceHub APK that's running on my Android phone. And I'm just screen sharing my phone over here. So in a minute, I'll scan this and show you how I can load that project in. Or the other option is I download the model. Once I download the model, then I send it over to Generalplus. And in a minute, you're going to see how George takes that model and then can integrate it directly into the Generalplus hardware. So you can test immediately on Generalplus, or you can test on a mobile device. So in this case, I'll use the mobile device. So I take my phone, I hit scan QR code, I just scan that QR code, and you can see that it loaded it from VoiceHub into my into my mobile phone over here. So now I can do quick testing where I can say Pikachu, Thundershock. And you'll notice that it recognized the wake words and then it recognized the command set. But I said that kind of in a more engineering kind of testing way. But real world, people are going to say things like, Pikachu, I want the Thundershock right now. And even though I said the wake word and I said that I want the Thundershock right now, as I mentioned earlier, because this is all phrase spotted technology, it recognizes the wake word. And even though if I have other things in front or behind the commands, it still recognizes it. So this provides very high accuracy without the need for an actual NLU engine running. Pikachu, discharge. So the can obviously a lot of times can just destroy a recognizer. In our case, it doesn't because of that phrase spotting capability. Pikachu, I want wild charge. I probably said it a little fast that time. Pikachu, I want wild charge. So again, just spots the wake word, spots the command set. Hey Pikachu, give me the thunder attack. So in a very natural way, no problem at all. So this is all based on truly hands-free, running in our VoiceHub tool. I've created a wake word. I've created a command set. I've downloaded that command set into my mobile phone over here. And again, as I mentioned, I can also download this into the Generalplus tools. And everything I've created here is formatted automatically for Generalplus. So I don't have to do any extra steps. It's a really nice solution for keeping it very easy and fast. So one of the things I wanted to demonstrate is our new Sensory Cloud. So this is very different. So the Sensory Cloud we introduced this at CES, and Sensory Cloud includes several technologies. One is speech to text, which I'm going to show you a demonstration of here in a minute, but also our biometrics, face and voice, as well as wake word revalidation and sound ID revalidation. So working with our partner Generalplus, we can run a wake word on device, very small, and then I can revalidate in the cloud. Or I can run the wake word on device, very small, and I can then go to the cloud where I have full-on speech-to-text dictation. Now, the beauty of sensorycloud.ai is that our cloud, we can actually provide the customer our container, and they can run this entire thing on their cloud. So it's, as far as kids and privacy and security, we remove all those hassles, allow the customer to run this directly on their own cloud. So again, in partnership with Generalplus, we run the local wake word. We can even run the local commands if we want, and then we can link to the cloud. So here, as an example, we've got different languages already supported in here. As you can see, there's several different languages. I'll stick with US English. And then once I hit the start button, basically this is the toys heard me say in this case Pikachu, and then I can say whatever I want. So as an example, we'll pretend I'm using the wake word on Generalplus, and I say, Pikachu, this is a really cool product. I can say anything I want, and this recognizes it. And then you can see everything that I said was recognized. Or now that we have this capability of speech to text, I can track kind of sentiment through text. So if I say something like, as an example, Pikachu, this is really stupid. I hate this toy. So you can see here that it recognized everything I said, and we could actually go back and analyze this thing and say, okay, well, look, they said stupid and they said hate. So we know that in this case, in a toy application, the kid's not happy with something. And so you could actually structure the software very differently to try and improve the relationship or have different types of things going on. And then again, because it's completely open, I can literally say anything. I want to make a red racing car with cool yellow stripes down the side and have it go really fast and make some cool noises. So everything that I said, totally recognized it, total speech to text. And again, this can run in a Sensory Cloud. This can run in our customer cloud. This could even run on-prem if we needed to. So this is all part of Sensory. I started with VoiceHub, which is a tool we created that allows for very fast development of custom wake words, custom commands, and even natural language grammars. And then also our new Sensory Cloud, which provides full speech-to-text dictation, which can link nicely with an on-device solution. This is all from Sensory and in partnership with Generalplus. Thanks all.
So I'm going to use the Generalplus IDE to import the files that Jeff provided just before. So let me jump into the IDE. Let me share my screen right here. So I'm going to import these files to my project. So I'm just going to add the necessary files, which is like 6 files. And then I'm going to build the project. Review all. So this is IDE is GCC based toolchain development system, and which you can edit, compile, download, and debug in one place. And then afterwards, you can download the code through the G+ Link Pro probe. So then we already download, we already built the project. Right now, we are going to download the code to the emulation board. So it's downloading and verifying. So I'm going to stop my share screen and then switch to the emulation board here. So as you can see, the board has a lot of interface, which is like a camera, the TFT, HDMI, and USB, and SD card, UR, microphone, deck, etc. So today we will mainly focus on the voice recognition, and we'll do the recording from the microphone and then do the recognition and then output the WAV files from the SD card. According to the phrase it detects. So let's run the demo.
This is sensory voice recognition demo run on GPM4. Say the wake up word, Pikachu, to start voice recognition.
So firstly, you have to say the trigger word and then following the command. So once the trigger word is detected, that the red LED will turn on and show you it is the wake up. Pikachu. Thunder shock.
Thunder shock.
So you will play a little bit a sound effect depending on your
Say
application.
the wake up word Pikachu again.
And then if you like no detection for the
Say the
trigger
wake up
word
word Pikachu
for
again.
the few seconds, then you will sleep. Pikachu. Thunder shock.
Thunder shock.
Bring it on. Quick attack.
Quick attack.
I want you discharge.
Discharge.
How about thunderbolt?
Thunderbolt.
Come on, wild charge.
Wild charge.
Thunder attack.
Thunder attack.
So basically, this is the demo. Is show you that it will spot the keyword and then spot the command, the phrase, and then play the sound effect automatically, and then it has a very nice response and then a very well recognition rate. So let me head back to the Anu.
So I see there's a question and San is going to answer that question live. The question is, what is the difference between English Kids and normal English in terms of a recognizer? So San?
Yeah, yes, the kit version, that means while we gather the data from the world, for example, US guide, we mainly in case for normal version, we mainly included adult data and some young and some kid data. But for the kid version, the percentage of the kids data will dominate. The more, for example, up to 70%, something like that. And so so at the end, this version more covering more about the kid sound, because the kid sound is quite different from the adult. So this mainly target for the kid version. This is the purpose of distinguish normal and the kid version. Is it clear? Yeah.
This is Jackie. So I just try to share some of my sound. I think the major difference between the VoiceHub is you can see from Ant's demo. So they have actually the database there. You can do the wake up word and also the command just by the typing. I know in the phony best, people always say that, but that's the must. They actually have a better of the database, and you can select like a kids version and also the adult version. So for example, like when George is doing the demo, actually George tried to insert a lot of the different things other than just the command set. You can see the stable of the response. So basically the keyword spotting is much better than what before. And probably I can walk through a little bit. There was a couple Q&A I already answered in the section. So the people are asking what kind of audio processing can be performed in the SPU being at GP43. So basically the GP43 have a built-in we call the sound process unit. You can see it's like a 16 channel of the sound processor card. So each of the channel you can define and mix different kind of thing. So the codec we have provide is like a PCM codec, ADPCM codec, and also we provide like a A1800, A4800, which is the Generalplus version of a subband coding, because in this kind of application, a lot of the time we can using the MP3 codec, but most people for that small speaker, they actually have a concern about like the quality will never get out in that speaker. So they want to make the code size smaller. So we actually provide the A1800, which is 18 kilobit per second mono, and the 48 is the 48 kilobit per second in the studio of the codec. And other than the audio, straight audio, it also supports standard MIDI. So you can put the MIDI file into the chip and the decoding by the library, and the timbre library, which is the sound source, can be ADPCM or PCM, and the file like a ADSR format of the MIDI. And the second question is talking about what is the standby current of this thing. Yeah, I know that's the kind of question people are always asking. So based on the demo right now we are doing, we try to run the CPU low to around like 100 megahertz. The chip can go up like 192 megahertz, but in this THF demo right now, we only use like 100 megahertz. And so each of the CPU and the clock setting in the DRAM will be changed based on which IP you want to turn on and turn off. So in the demo, the George just showed is around just a little bit about 100 milliamp. And it's always we can add some of the circuit and outside like analog detection. So we can be using like a wake up by the audio, or even we can put some PI in the front. So basically you can have a multiple stage, like you can have a CPU whole sleeping and wake up by the analog of the audio, or you can someone walk by and the PIR sensor wake up the CPU, and CPU immediately go to the full speed of running and pick up the wake up wall. And when that stage is like 100 milliamp for the operation. And let me see. That was a new question coming for where is the development system? Okay, so basically, I think for the developing system, we can provide, like George been talking that thing is to say, we can, let me see. Okay. So basically, we will be providing SDK, including the hardware emulation board you can see in the demo. And also we have we call the G+ Link, basically is our JTAG tool. And also we provide a full function of IDE based on the GCC. So that's a free to download from the Generalplus website. But I think you still need to contact our local sales, for example, me, to get all the SDK, including we call the platform code, which is a big package of the demo code, including how to enable each of function inside the chip for the hardware. And we have the demo code for each individual application, and also the driver, L1, L2 driver for individual hardware. And let me see. If we want to using the testing GP subband coding quality, how can we recoding the audio file? Okay, so basically we have a tool in our website called the ABC Converter tool. So you can input any waveform, like a 44.1K standard waveform, and you can convert into each of the format I just talking, including the ADPCM. We actually have a multiple version of ADPCM, like a standard 4-bit, modified 5-bit, or the PCM 66, those kind of things. So we have a software offline. You can convert the audio file into the format we need to. For example, you want A1800, so you basically just drag and draw a lot of the audio file into that tool, and you can output it with a .A1800, and it can play back by our SDK, have a library. And let me see, how much MCU resource are using? Actually, George, do you know the answer about this one? I think this is question, how much CPU resource are using?
The resource and the command, I still have not a very specified data, so I can share the data after I get the command or the CPU calculation afterwards.
Actually, in case depend on the size of the model, because we can allow the customer select different model size. Maybe they want to have a simple version or easy one, they may select a smaller model. Under this situation, I believe that the processing power is about 20 megahertz, something like that. And then in case they want to have a bigger models, and then very complicated, maybe they will need to up to 50 or 60 megahertz, something like that. So we can calculate the processing power and also the power consumption under this way. And then suppose Sensory and Generalplus will provide just data later, okay, in a better format.
Question I forgot to answer.
Okay. Now, I will go ahead and put some links in the chat to everyone. Oh, okay. It looks like we have one more question. So it says, could the solution pick out the kids' words in a noisy environment? I'll let someone on the panel take that. I will say that I know that sensory models work great in noise. And if we trained our models to work specifically for kids, I'm sure it works. I'm sure it works great in noise, but that is my instinct, but I'll let someone with some experience with model follow up with that.
Maybe I can give a reference information about the signal to noise ratio. For normal noise, because very typical noise, we can't see this one because the sensory model trained up with very typical noise source. And then the signal noise ratio is about 6 dB to 9 dB. So, and of course, some very typical noise, our signal noise ratio can be even lower. But I think this good enough. Most of the situation we can handle our model in the office environment. This is no problem. The mic distance is about 2 meters, something like that. But of course, you are in a very typical Chinese restaurant, then maybe it has some problem. But we can handle this in a specific case. We can talk with the customer in a better manner to understand their concern and something like that. Yeah, we could provide some professional opinion, and actually we also have a lab in Sensory. We can provide some service to handle this kind of noise issue. Yeah.
Yep, and San is mentioning our internal testing system that we have with Vocalize, and we can tune models to customers' needs. So if we want to make sure that the model works in a noisy environment, we can work with our customers to do that.
Yes, this is the way. Yeah.
So I think that's just about wraps things up. I want to thank everyone for joining and for bearing with us today. And we'll see you next time.